Okay, so we want to, I want to give you a little bit of background on the second order differential equations. Um, the second order differential equations, um, these are equations that come in the standard form, which is given by a uh, d squared y dx squared plus b dy by the x plus cy is equal to f of x. So that's the standard form of a second order differential equation. And you find that the kind of question that you get when pertaining to this differential equation would be to say, solve the differential equation. And when you solve the differential equation, you either get what we call a general solution or a unique solution, or sometimes referred to as a particular solution, depending on the information that is given in a question. But in general, the standard solution to this differential equation is actually given by y is equal to yc plus yp, where yc is what we call the complementary function or solution, and yp is what we call the particular solution. So those are the two parts of the solution that you get for a second order differential equation. Now, the question would be, how do we get the complementary solution and how do you get the particular solution? So I'll just give you a brief summary of how to find or um, how to get the complementary solution YC. So to get the complementary solution YC, you look at your differential equation, and on the left-hand side of the second order differential equation, you can get what we call the auxiliary equation. And this auxiliary equation would be given by, for example, if we let m equals to dy by x, it will be given by a m squared, so that's a m squared plus b m, and of course plus c, which is then equal to 0. And that is the auxiliary equation. And you can see that this auxiliary equation comes in the form of a quadratic equation. And the next thing then would be, after getting the auxiliary equation, is to solve that auxiliary equation. And the auxiliary equation, it being a quadratic equation, when we solve a quadratic equation, number one, we can get two unequal real roots. So if we get two unequal real roots, then you'll find that your complementary function yc will take the form a e to the power m1x plus b e to the power m2x, m1 and m2 being the solutions of the quadratic equation, which is the auxiliary equation. Number two, you may find that you can get two equal real roots, two equal real roots, real roots. And if you get two equal real roots, you'll find that your complementary function will take the form a e to the power mx plus bx e to the power mx. So that's when you get two equal real roots, m being the solution to the auxiliary equation. And number three, you may find that you can get what we call complex roots. If you recall complex numbers, when you dealt with complex numbers in some courses earlier on. So when you have the complex roots, then it follows that your YC is going to take the form YC is equal to e to the power ax into a cos bx plus b sine bx, like that. And remember, a complex roots, a complex number is given by, say, if we have a complex number z, z would be given by a plus bj, like that. That's a complex number, where a is your imaginary part and b is your, sorry, where a is your real part and b is your imaginary part. So this is the real part and this is the imaginary part. Now, if you check on your solution of the complex roots, you have e to the power ax. This a is coming from the real part of the complex number. And also you have the b part here, which says cos bx. That small b, or small b, is coming from the imaginary part of the complex root. So that's what the complex root gives us as a solution. From here, depending on how, on whatever second order differential equation that you are given, depending on the roots that it takes, the complementary function will take either of these forms depending on the roots. So that means if you have two unequal real roots, your complementary function takes this form. If you have two equal real roots, the complementary function takes this form. If you've got two complex roots, then the complementary function takes this form as well. So that's how to get the complementary function of a second order differential equation. Now, it is also important to note that if f of x from the second order differential equation, if f of x is equal to 0, then it follows that your yp is also equal to 0. If f of x is equal to 0, then yp is also equal to 0. So now I want us to quickly look at a problem where your f of x is actually equal to 0. So we can be able to solve a differential, a second order differential equation. So let's look at an example. I'll pick one example, or rather one question from my list of questions here. So if we are given the following differential equation to find a solution, we have here d squared y dx squared plus 2 dy by the x plus y is equal to 0. So solve the differential equation. Now, remember, number one, for us to solve this, we must get what we call the auxiliary equation, which in this case is given by m squared plus 2m plus 1 being equal to 0. And now we must solve for m on this auxiliary equation. If we solve for m here, we are going to get m plus 1, m plus 1 being equal to 0. And that means m is equal to minus 1 twice. So in other words, we have two equal real roots. So remember, we said if you have two equal real roots, yc would take the form a e to the power mx plus bx e to the power mx, like that. So it follows therefore that the complementary function for this would be equal to a e to the power minus x, remember m is minus 1, plus bx e to the power minus x. So this is our complementary function. So it follows therefore that the solution to this second order dE would be given by y is equal to a e to the power minus x plus b x e to the power minus x. Note that we said if f of x is equal to 0, then it follows that yp would also be equal to 0. So if your f of x is 0, then that means yp is equal to 0. So there's no need to calculate yp. So all you need to calculate is yc, the complementary function. So we have literally found the solution to this differential equation. And I also want you to note that this solution that we found here is actually a general solution. It's a general solution. The reason why we call this a general solution is because we are not given in this particular question the conditions to find that capital A and capital B. It is possible that we can be given conditions to find A and B, those capital A and B. And if we find those capital A and B, then that solution ceases to be a general solution, but it becomes what we call a unique solution or a particular solution for that differential equation. Now, in the next video, I'll look at some more questions on the second order differential equation, and also I'll show you how to calculate the particular solution yp of a second order differential equation. And I would like you to subscribe to this channel. Also like and comment on this channel as well. Thank you.